Hello and welcome. Introduction. Now in this video I'm going to show you how to install and use FreeRTOS with the Arduino Uno R3 without using Studio 7. Now FreeRTOS is a small, simple real-time operating system, or RTOS, designed for embedded system. I mentioned this in my earlier videos. It is written mostly in C, but there are a few assembly functions. Now, these assembly functions are there to cater for the architecture-specific requirements. All right, because each CPU's architecture differs a lot or in a few places. All right, so the assembly functions are there to cater for these architecture differences. Now, there's also a tickless mode available to cater for the low power applications. Installing FreeRTOS. Now, to install FreeRTOS, you're going to have to download and install Arduino IDE version 2. My version is Arduino IDE 2.3.2. All right, so here is the toolbar. All right, and here is the text editor area, and here is the sidebar, which is available in the Arduino IDE version 2 upwards. Now, I'd like to briefly look at the sidebar here. So the first symbol here, like a folder, that's the sketchbook. All right. Then this little symbol, icon here, is the board manager. And here, this icon or symbol here, that's the library manager. And here is the debugger. The icon here denotes that the debugger is not available for the Arduino Uno R3. All right, so I don't know why that is, but it is not available for Arduino Uno R3. And here, the last icon here, that's the search icon. Now, to install FreeRTOS in Arduino IDE, there are two ways of doing it, or two options. Now, the first option is using, if you go to the toolbar here, and you click on Tools, pop-up box like this will come up. Scroll down and look for Manage Libraries option. All right, then you click on that one. Or another way of doing this is to click on this icon here, the Library Manager. Now, either way, or either options will bring you to this this part here. All right, don't know what you call it, or panel. All right. Now, in this search box, all right, you type in the word FreeRTOS. Just type FreeRTOS. Casing doesn't matter here. You type FreeRTOS, and then you press Enter, and you will see this appearing, this panel here, which says FreeRTOS by Richard Berry. All right, so you need to get hold of this, and then you click on Install. Now that will install FreeRTOS onto your Arduino IDE 2.3.2. Creating tasks. Now here is the code for creating one task. Now, to use FreeRTOS in your Arduino project, we need to include this header file, which is Arduino_FreeRTOS.h. All right, so that's the first thing you need to do. And then in the void setup, we have, I'll come back to this serial.begin in a minute. So the first one, the first function we're going to call is the xtask create. All right, and these are the parameters for the function. We'll come to the details in a minute. And then the next following the xtask create is the vtask start scheduler function. All right, and here is the task itself. All right, so all tasks are implemented as C function. Now, in this task, there's a parameter here, this asterisk PV parameters. This is the pointer to void. PV here is pointed to void, and it allows the task parameter to receive a parameter of any type. Now we'll come to this part in more detail in a few moments, but for this program, you please accept it for the time being. So this is the task. Now, in the purpose of the task is to use the serial.print. Hence, in the void setup, we have a serial.print with a baud rate of 9600. And so here in the task, we say serial.print task is running, and then with the new line. All right. Then we delay it for 100 milliseconds. All right, so this is the for loop in endless loop format. So this will keep printing this message task is running well, forever basically. Now the next one here, void loop brackets. This is needed. All right, in all Arduino program, we need to include this, even though if we do not have anything inside the void loop. Okay, now let's take a closer look at the xtask create function as mentioned earlier. So in the xtask create function, we have the first parameter vtask1. Now this basically is a pointer, right? It points to the task. The next one, the next parameter, this is the name of the task and is used for debugging. I called it task1. Now you don't have to call it task1. You can call it anything else, but it has to be in double quotes. Next comes the depth of the stack or the size of the stack. Here I've just chosen 100. I think it should be enough. And then the next one is the task parameter, and because in this example we are not using the task parameter, we leave it as null. Then the next one here, this is the priority of the task, and here in this example I have assigned priority 1, so that hence the 1. And then the final parameter, this is the task handle. Now because we're not using the task handle, we give it a null, right? So this is the xtask create function. Next one is the vtask start scheduler. So basically this function starts the RTOS scheduler. Now once the scheduler has started, the RTOS kernel will then have control over which task to execute and when to execute the task, right? And we'll come to the first demonstration 1. Hardware requirement. Now for this demonstration, you will need an Arduino Uno R3 connected to your laptop or desktop. Okay, so I have the Arduino IDE version 2 loaded here, and I have also prepared the code, so it's all here. And this particular demonstration is to demonstrate one task, how to create one task using FreeRTOS in the Arduino Uno IDE environment. All right, so very quickly, so I have the Arduino underscore FreeRTOS.h header file here, and here is the void setup function. So here is the serial begin with the baud rate 9600, and here is our X task create with all the parameters in here, and followed by a V task start scheduler. And here is the task itself, and basically the task will output this message onto the serial terminal, and then followed by a delay of 100 milliseconds. I'm using the for loop in this example, and then not to forget the void loop. All right, so I will upload this to the Arduino Uno R3 board, which is already connected to my laptop. Okay, so now it's compiling and it's uploading now, and it's been successfully uploaded. So we can now, it's already running, so we need to open up the serial monitor, which is up here, the right hand corner. Click on this symbol, and you see here at the bottom, if I just stretch this up a little bit, and the message task is running. So our task is running in the serial monitor. Creating two tasks. Here's the code for creating two tasks, and as with the previous example, we need to include this header file, the Arduino underscore FreeRTOS.h header file. Now in the void setup loop, I have the serial.begin function as in the previous function, because in the previous example, because I'm going to send out a couple of messages now to the serial terminal. So the baud rate I've chosen again is 9600, and then this is followed by these two X task create function, and then followed by the V task start scheduler function. Let's take a look at the first task, right? So in the first task, I used the while loop, and in the while loop, I have the serial.print, and I'm printing the message task 1, and then followed by a delay of 100 milliseconds. And this is in a endless loop using the while loop. Then creating the second task. This is all identical to the first one, the first task, except in the serial.print, I have a slightly different message. I have task 2 as the message. And again, this is in a while loop. Now, if you recall in the previous example, that is the creating task 1, I used a for loop, but here I've chosen to use the while loop, just to demonstrate that you don't have to stick to a for loop, but you can also use a while loop to create the tasks. Okay, so we're back in the Arduino IDE again, and I have uploaded the code here. Now this assume that you have your Arduino Uno R3 connected to your laptop or desktop. Now, if we look at the code here, basically it's almost identical to the previous demonstration, except that we have this second X task create function here, because we are creating two tasks. All right, so we should be familiar with this by now. So we have the header file Arduino underscore FreeRTOS.h. This is the void setup here with the serial.begin and the 2x task create function, followed by the v task start scheduler function. And then here is the first task. And this time I'm using the while loop in the task, and I'm using the serial.print to print the message task 1, and then followed by a 100 milliseconds delay. So this is task 1. And then the second task is basically is identical to the first task here, except I'm printing task 2. Again, I'm using the while loop for this task. And then finally, not to forget the void loop. All right, so I've connected my Arduino Uno to my laptop. So I'm going to upload the code to the Arduino Uno and watch the output panel here. So it's uploading, and it's done uploading. It's finished uploading, and it's successful. No error messages. So it's already running. So let me just go open up the serial monitor, and we should see the message task 1, task 2. Okay, here we are. Let me just, all right, so you can see it's like running. Okay, so that's it for demonstration 2. A task within a task. All right, so here's the code for creating a task within a task. So we start off with including this header file Arduino underscore FreeRTOS.h, and then in the void setup function loop here, we have the serial.begin with a baud rate of 9600. This is required because I'm using the serial print to print the message later on. So this is followed by x task create function, and here are all the parameters, and then followed by the v task start scheduler function. And then here we defined or declare, or sorry, define the task 1. So it's v task 1. You don't have to use this name. You can use any other C function, valid C function names. And then we have the void asterisk PV parameters in here. Then followed by an X task create task 2. So within task 1, we're creating task 2. All right, hence a task within a task. Now in task 1, the job of task 1 or the function of task 1 is simply print this message, task 1, and then delay by 100 milliseconds. So using the for loop, that's the task for task 1. But within task 1, we are creating task 2. All right, so let's look at task 2. Task 2 is pretty straightforward. It's a for loop with the serial.print, the purpose being to print this message task 2 followed by a delay of 1000 milliseconds. So that is in itself task 2. Now, before we end the code itself of the program, we mustn't forget the void loop function. Now, all Arduino sketches requires this. Demonstration number 3. Okay, so for this demonstration, I have already uploaded the code here. So here we have the header file, the Arduino underscore FreeRTOS.h. Then this is the void setup, and I have the serial.begin here, and then the x task create function, and then followed by a v task start scheduler function. And here is the task 1, right? And the only difference this time is I'm creating task 2 in task 1. So here I have the x task create task 2 for v task 2. So we're creating a task within a task. And for task 1, its purpose is to print the message task 1 onto the serial monitor. And then we have task 2 here defined, and the purpose of task 2 is to print this message onto the serial monitor. And last but not least, the void loop. All right, so I've already connected my Arduino Uno to my laptop, so I'm going to upload it to my Arduino Uno. Watch this panel, output panel here. It's uploading, and it's done uploading. Let's close this. Everything is fine. So let me just drag this up. Now let's open up the serial monitor. And here we go. We have task 2, task 1 all printed out onto the serial monitor. Creating tasks using the task parameter. So first of all, let's remind ourselves what is the task parameter. So here what I've done here, I've extracted part of the code from the earlier example. So I have the void setup here, and I begin with the serial.begin with a baud rate of 9600, and next follows the x task create. Now notice within the x task create function there are a number of parameters, and I've listed it out here, and I just want to go down the list and focus on this one here, this parameter, and this is the task parameter. Now in the previous examples that we have encountered, I have set it at null because we're not using the task parameter. So this is the task parameter within the x task create. Okay, so let's see how we can use the task parameter to create tasks. So here we have the Arduino underscore FreeRTOS.h header file. We need to include this. And then let me just go down the setup function here. Here we have the familiar serial.begin with baud rate of 9600. And here we have the x task create. This is the function name of the task, sorry. And if you go along here, now notice here the task parameter here, this time we have this void asterisk in brackets PC text for task 1. Now this is used to pass the string to be printed using this task parameter. All right, we're going to print the string using the task parameter. Now let's go back up here. Here we have a declaration here, static constant char asterisk PC task for task 1. So basically we declare a static constant character pointer. This is a pointer, and then we assign this string here or data to the character pointer. Now the const here, that is to ensure that the string or data remain constant when the task is being executed. All right, so that's the whole purpose of this thing here. And then let's go back to the void setup briefly. Here we have the v task start scheduler function. Okay, so this is the task, and the name of the task is v task function. Now you don't have to use this name; it can be any valid C function name. And here we have void. That is to indicate that the function is not returning any value. And here, void asterisk PV parameters. This is used to pass the string or data into the task itself. And here we have a declaration of a pointer, PC task name, asterisk PC task name of the type char. And here, this line here is using the PV parameters to assign the string or the data to PC task name. And then here in the for loop, we have the serial.print that would print the string that is been assigned to PC task name, and followed by the delay of 100 milliseconds. And so this is the task itself. And here I have this diagram, basically summarizing of what had been said. So here we have the main function here, and here we remember we use this static const char asterisk PC task for task 1, assign this. Basically we're assigning this string to this, and then in the X task create we use the task parameter to pass the string to the task itself, and the task will then print the string to the serial terminal. I hope this diagram helps to understand the whole mechanism. And we have demonstration number 4. Okay, so here is my code, which I've uploaded to the Arduino IDE. So first off, we have this Arduino underscore FreeRTOS.h header file, and then followed by this declaration of the constant character pointer. All right, and then followed by a void setup loop here. And we have in the setup, we have the serial.begin, we have an X task create, and then we follow by a V task start scheduler function. And then here is the actual task. All right, and this is the for loop, and this is the serial.print here that will print the string that is being passed to it later on. And not to forget, last of all, but not least, the void loop. All right, so as mentioned earlier, I've got my Arduino Uno connected to the laptop. So upload the code and watch out for the output panel. So it's compiling the sketch, uploading it. It's done compiling and uploading is done. There's no errors reported. That should be good. So we're going to stretch this up a bit. Open up the serial monitor. Wait for it. And we have the message task 1 been printed. All right. So creating tasks with LEDs. All right, so this example demonstrates how to use FreeRTOS to create tasks to control 3 LEDs. So here's the sketch, and we start off with the include the Arduino underscore FreeRTOS.h header file. And this is followed by 3 defined directives. And example here, we define pin 6 as red, pin 7 as green here, and we define pin 8 as yellow. All right, and then in the void setup part, we have 3 X task create function, and then followed by a V task start scheduler function. All right, so this would be the void setup. Now the task itself, here the first task I've called red LED task, and then followed by void asterisk PV parameters. And in the task here, I have a pin mode, and we define pin red pin or pin 6 as output mode. All right, and then in the while loop, I have this digital write comma digital read brackets red up arrow with a 1. Now this digital write, this line of code, basically we read the current state. So digital digital read will read the current state of the pin, where the red LED is connected, so we'll read the status of the pin, and if the pin is high, it will change it to a low, and if it's a low, it will change it to a high. Basically, this line of code here toggles that pin, which happens to be the red LED, and then followed by a delay of 300 milliseconds. And here are the next 2 tasks. So there's the green LED task, and basically, if you look into the task, the code itself is identical to the red LED task, except that we are using green here, and there is a delay of 600 milliseconds. Here again, this part here will toggle the LED. And then the last task, but not least, is the yellow LED task. Again, if you look at it, it's identical to this, except for the pin being used. And again, it basically toggles the red yellow LED, and the delay I've used here is 900 milliseconds. And last of all, not to forget, the void loop, which is required by all Arduino sketches. Demonstration 5. Right, to test the code, we require some hardware. Now here is the schematic or circuit diagram. It's very straightforward. Basically, we have a light emitting diode or LED. Connect one end of the LED, the anode is connected to a pin of the Arduino Uno, and then the other end, the cathode, is connected to a 220 ohm resistor, and the one end of the 220 ohm resistor is connected to ground. Now let's take that's for the red LED, and the same applies to the green and the yellow LED. The green LED is connected to pin 7, and the yellow LED is connected to pin 8 of the Arduino Uno. And basically here on this side is the wiring diagram for this schematic diagram. Okay. Okay, so for this demonstration, I have my hardware set up here. As you can see, there's a red LED, green LED, yellow LED. And on this side here is the Arduino IDE, with the code loaded. So first line is the header file Arduino _FreeRTOS.h, followed by this definition here. Pin 6 is defined as red, pin 7 defined as green, pin 8 defined as yellow, and then followed by the void setup. There's 3 tasks here. X task create, 3 of these tasks, one for creating the red LED, green LED, yellow, then followed by V task start scheduler. And then from there on, we have the red LED task, and basically that toggles the red LED with a delay of 300 milliseconds. Then we have the green LED, which is this one here, and there's a delay of 600 milliseconds, and this line here is to toggle that green LED. And finally, we have the yellow LED task, and the main function of this task is to toggle the yellow LED, and it has a delay of 900 milliseconds. And then last but not least is the void loop. Alright, so I've already connected the hardware up, as you can see, to my laptop. Then what I need to do now is to upload the code to the Arduino Uno, and we should then see the LEDs blink. So watch the output panel and watch the camera here. It's compiling now the sketch. It's uploading it, and it's done uploading. As you can see, the red LED, green LED, and yellow LED blinking. Alright, so that's it for this demonstration. Okay, so that's it for this video. I hope you have found the contents useful, and I'll see you in the next video. Bye!